Welcome to our unit on organic chemistry. So organic chemistry is the chemistry of molecules related to life. Okay, organic means living. So some things that you probably remember from biology class, organic molecules are things like sugars, amino acids, DNA, RNA. You get into a very advanced class, you might actually start manipulating these things. But we are going to be focusing, like most of organic chemistry, on carbon compounds. Okay, so these all have carbons in them. The vertices on the edge of the glucose, the vertices on the bases in the DNA. You can see the carbon in the center of the amino acid. So organic chemistry primarily focuses on carbon-based compounds. So we're going to start out with the hydrocarbons, the simplest organic molecules. The name comes from the fact that it's made out of hydrogen and carbon. Okay. One thing that's going to be new for us is that while you can use Lewis structures to show what's going on here, we're actually going to use this skeletal formula. Okay. So Lewis structures, you know how to do those. The structural formula, that's when I was writing things out for you so that you could kind of see how the bonds were supposed to be. And then the skeletal formula is a drawing where the points and vertices of the lines represent carbons. Excuse my cat meowing. So here, the open carbons are, or the open ends are a carbon with 3 hydrogens. And then the vertices are going to be carbons with 2 hydrogens, as long as everything is a single bond. Okay. The skeletal formula makes it so that it takes a lot less time to write out your organic molecules, especially when they get into having very long chains with 8, 9, 10 carbons on them and other things as well. Okay. So the key to the skeletal formula is to make sure that you understand where the carbons are, and you don't forget that that does also include the hydrogens. Okay? So a couple more examples of this. We've got a double bond here. Shape-wise, and I'm just going to cross this picture out at the bottom here because we need to fix that one for shape. But shape-wise, the zigzag comes from the fact that each carbon has 4 atoms bonded to it, so it's a tetrahedral shape. You can't form a straight line with those. It's going to form a zigzag. If you grab a model kit and put some together, you'll see it happen. There's no way to connect single bonded carbons in a straight line. Okay? Double bonds, what they do is they kind of flatten the portion of the zigzag, and then around each carbon is bent. Okay. The all single bonds gives you the full zigzag shape. And then when you have a triple bond, you have 2 atoms attached without any lone pairs, so it should actually form a linear shape. So the correct drawing here would look like this, where you've got carbon, 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 carbon. Okay? So the drawing as far as triple bonds is probably going to be the hardest one to remember. It's easy to kind of get stuck doing the zigzag. Just keep in mind you do need to account for these changes in shapes. So let's get into naming. Hydrocarbons with only single bonds are called alkanes. Okay. Alkanes have an ending specific to them, which is ane. Each different new type of organic compound we talk about is going to have a different ending. But something that's going to stay the same for all of them is the prefix that we use to denote how many carbons are in the chain. Okay, so we're going to start out simple, things that are all straight chains, no branches, because then there's a complication to the naming. But these prefixes, meth stands for 1, eth stands for 2, prop stands for 3, bute stands for 4, pent for 5, hex for 6, hept for 7, oct for 8, just the oct, not the octa, and then non and dec. Those you're going to want to memorize. Okay, we will use those quite frequently. You're also going to need to memorize the endings that go with the different type of compounds, like alkanes, ane. Okay. As far as shaping and drawing these go, the shape we had on the last slide, what would that be called? If you look at it, there's 1, 2, 3 carbons, so that should be propane. Okay. If you wanted to draw butane, you add one more line so you get an extra carbon on there. Alright. If you notice a pattern here, it's always one line fewer than the number of carbons. So for decane, how many lines do you need? So there's 9 lines here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 carbons. Okay? Especially as you get into the longer ones, it's always a good idea to double check and make sure you have everything there and you didn't draw an extra part of a line or your short one. So, double bonded hydrocarbons, okay, we call those alkenes, and they take on the ending ene. Okay, the beginning of the name is going to include a number indicating the position of the double bond. Now that's only applicable if there is more than one position for it. And then it's going to be followed by the prefix number of the carbons in that line, and lastly with the ene ending. Okay, so ethene and propene. You notice they don't have numbers at the beginning. Ethene makes sense. There's nowhere else that double bond can possibly go. Propene, on the other hand, you could say, draw it this way. With the double bond up top. The thing is that you're not actually changing the molecule doing this. You're just flipping it around. Okay. When it comes to putting a number on for where the double bond falls, you always want to use the smallest number possible. Because drawn the left picture of propene, you can tell that the double bond falls on the first carbon. Okay, so you say 1 propene. If you use the other one, it looks like it falls on the second carbon, and you'd say 2 propene. But those are the exact same molecule, and we don't need 2 different names for the same thing. So as a rule, you always want to use the smallest number possible. Okay, so that's why, say for this 1 butene, if you were to count from the other way, it'd go 1, 2, 3, and you might say 3 butene. Or if it was drawn in the reverse, you might say 3 butene. But if you count from the other direction, 1, 2, 3, 4, you can see that it's a 1 butene. Okay, so you always go with smallest number possible. Now, butene requires numbering because you can move the double bond into the middle and then having 2 single bonds on the outside, and that is a completely different molecule. Okay, so the numbers are used when you get to having enough carbons to actually put the double bond or triple bond in a different place. That's when you need to actually start using the numbers. So, why don't you pause the video, see if you can give me a name for the top structure and the bottom structure, and then draw what 4-nonene should look like. And then pick the video back up, and I'll show you what you should have. So, for me, when it comes to having problems like this, I always start by counting my carbons. 1, 2, 3, 4, 5, 6, 7. Okay, because that's going to give me my prefix, hept. And then I see the double bond, so it's going to be ene. And then heptene, it's got 7 carbons. It's definitely going to be big enough to have that double bond fall in more than one place. So I'm going to count 1, 2, 3. Double check, make sure that's the smallest number. 1, 2, 3, 4. If I went the other way, I'd be calling it 4, so 3 smaller, 3 heptene. Okay. When I have a name and I need to draw things, I still go in pretty much the same order. I start with looking at my prefix in the beginning, non, that means there's going to be 9 carbons. C-ene, which means that I'm going to have a double bond somewhere. And then I look at my number, that double bond is going to be at the 4th carbon. So I've got 1, 2, 3, 4 carbons. So I'm going to throw my double bond in there. There's my 5th carbon. 6, 7, 8, 9. I'm going to double check. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so I definitely have my 9 carbons. I have my double bond at the 4th position. And that's fine. Now, you go far enough into organic chemistry, there is a right way to draw your double bonds, and there's another thing we could add to the name. But for my class, I would accept this picture, or I would accept this picture. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay? Because we're not going to go through the rules as far as when on a double bond you bring it back down or you bring it up. Okay, so I'd accept either picture for foreknowing. The last one. So here we have 2 double bonds. Okay, so I know we haven't talked about this yet, so if you weren't sure what to do, no big deal. But first off, count your carbons. I've got 1, 2, 3, 4, 5. So that's going to be a pentene, because I have double bonds. Now I need to number where the double bonds fall. Since there's 2 of them, I'll need 2 numbers. Okay, so I've got in this direction 1, 2, 3, 4, 5, and in this direction 1, 2, 3, 4, 5. If I go from left to right, my numbers are smaller, so it's 1, 3 dash pentene. Okay, so nomenclature-wise, you do need to write things out in this kind of formatting. If you have more than one number, you put a comma in between. If you have numbers and words, there's always a dash in between. Okay? So, let's see. We've already kind of talked about the second question. Why don't you need to number a double bond on ethene or pentene? That's because there's nowhere new to put the double bond to actually make a new molecule. But why is there no methene? So hopefully you think about it for a second. To have a double bond, how many carbons do you need? 2. And what does meth mean? 1 carbon. Okay, so you'll never see a methene. You'll also never see the prefix meth used with the triple bond either. Okay? So triple bonded hydrocarbons. They are called alkynes. They always take the ending Y and E. Okay? And then the beginning of the name is going to go much like the beginning of a double bonded carbon or an alkene. You're going to include a number with where the double bond falls. You're going to also use the prefix for the number of carbons in the chain, and the only difference from the double bonds is the ending. Okay? So again, ethyne, there is no number there because there's only one place to possibly put that triple bond. Propyne, again, even if you move the double bond, you still have the exact same molecule. And then look at the last one carefully. There is some issues with the name. I want you to see if you can spot them before I talk about it. First thing, if you're having a hard time saying this, that A is not supposed to be there. It should be pentyne. The prefix is pent, not penta. Okay? And then this is numbered going left to right. 3, 4, 5. If you go right to left, you have 1, 2, 3, 4, 5. You can get smaller numbers going that way. So this should be 1, 3 pentyne. Okay? So, this is a review of everything. I want you to, again, pause the video, try and see if you can do it on your own. But the fourth one here, first you gotta circle which one's the right picture, then name it. So, pause it, take your time, and then when you turn it back on, I will explain. Alright, so first one. If I have words, I go to my prefix first. It's going to tell me oct tells me I have 8 carbons. Go to my suffix next. Ene tells me that I'm going to have a double bond, and then I look at the number. There's going to be a double bond at the 3rd position. So I've got 1, 2, 3, double bond. There's my 4th carbon. 5, 6, 7, 8. Double check. 1, 2, 3, 4, 5, 6, 7, 8. We're good. Okay, this one also can be drawn the other way. Let's make sure my double bond looks like it's there. 1, 2, 3, 4, 5, 6, 7, 8. Could be drawn that way as well. Okay? So, if I have a picture, I count my carbons. 1, 2, 3, 4, 5, 6, 7. So that's going to be a hept. And then I look at it. It's all single bonds. I don't have any double or triple bonds, so that means it's an alkane with an ane ending. Okay. And then 2 hexyne. So hex means 6. Ine means triple bond. 2 means it's going to be at the 2nd position. So here's 1, 2. 1, 2, triple bond. There's my 3rd carbon. 4th, 5th, 6th. So I've got 1, 2, 3, 4, 5, 6 carbons. And I drew my triple bond linear through the carbons. Okay? So that should, of course, hopefully help as far as deciding which picture is correct. That's this one. Alright, I'm going to count my carbons. 1, 2, 3, 4, 5, 6, 7. So again, I've got a hept. It's a triple bond, so YNE ending. And then to count, 1, 2, 3, 4, 5 when I hit my triple bond, or if I count the other direction, 1, 2. 2's the smaller number, so it's 2 heptyne. And then this last one, I hope you realize there's once again a error in the name here. 1 for butene. Okay, butene has 4 carbons. I'm going to have a double bond to begin with. That makes sense. There's 2, there's the 3rd carbon. And then if I draw the 4th one, I've got no room to put a double bond in there afterwards because I'm done with my carbons. So this one is incorrectly named. You always want to name from the carbon you begin at. This should be 1, 3 butene. So I put my carbon down there, or my double bond down there. Okay? So, if you have questions, ask them, but we will keep working with this in class.